Hello friends, in this chapter we will further move into the lectures of the STAAD Pro. In the previous chapter we analyzed a beam. In this chapter we will analyze a frame. Before moving in, make some configurations as per your requirement. Change the base units if you want, also change the codes, alright, and also you can change the axis orientation. So after you have made the configuration as per your requirement, so go to new project, so click on the new project option here. After that, choose space option, so name this file as frame practice. You can name any other thing also. So choose the location, and from here also you can choose the unit of the length and the unit of the force. After selecting these options, click on next, and here choose add beam option, and after that click on finish. So you land up here, just close this window. Now let us see the frame that we have to model. I'll draw a frame. So this is the column, this is the beam, and this is another column. So let me do this as hinged, and after that let me draw another leg. So this is the fixed support. Okay, so let us say that the distance from here to here, suppose it's 5 meters. This distance is also 5 meters, and also suppose that distance from here up to here, so this distance is, suppose let it be 1 meters, so this is 4 meters. Okay, and let us suppose that this distance is, okay, so let us suppose it's 3 meters, and this distance is also 3 meters, or you can give any other distance. Okay, so now let us apply the loads. So we'll apply the UDL here in this span. The UDL will be 4 kilonewton per meter, and also apply the point load at this point. The unit will be 10 kilonewton value, and let us apply the UVL here. So we'll apply the uniformly varying load. Okay, it's here 7 kilonewton per meter. On this face we'll apply the load like this. So let us assume that this is 2 kilonewton per meter. So the axis system is, upward is Y, to the right it's X, and towards you it's Z. As I've already talked about the axis system and the nodes in the previous chapter, so in this chapter I won't be going into that, so I'll directly move into modeling of this frame. I'll begin from here. So this will be our origin. So the first node will be at the origin, and its coordinate is 0, 0, 0. So I'll put this value. So first node is at 0, 0, 0. The second node, so you can make any node as the second node. You can make this node, or any node. It is better to go systematically. This will be my second node. So the coordinate of this node is, assuming that this is the origin, the coordinate of this node is 0 in X, 5 meters in Y, and 0 meters in Z. So it's 0, 5, 0. You can see that so you got a point in the upward direction. So right now we are doing in a single plane, that is we are working in the XY plane. So what I will do is that I'll take the view from Z axis, that is the XY plane view, so that I can see the things in vertical. Okay, next point is, I got this point, so now I'll make this point. So the coordinate of this point is, so in the X direction it's 3 meters. Okay, so this is span in X meters, and in the Y direction it's 5 meters. All right, so x5, x3, y5 and z 0. So we don't have anything in the z direction, so its x is 3 and y is 5, so we got a point over here. So next thing that you can do is either you can draw this point. All right, so you can draw this point, or what you can do, you can just copy this point here. So let me show you how we do that. First click on this window over here. After that, select this cursor, so nodes cursor, and select this node, so it turns into red, which means that it has been selected, and also over here it will be highlighted. So now press Ctrl+C, that is copy. So once you have hit Ctrl+C, press Ctrl+V. Now it asks you where you want to copy. So I want to copy it in the negative y direction. I am copying this node here. Upward is positive, downward is negative. So the distance is -4 meters, because the distance from here to here is 5 meters. The distance from here to here is 1 meters, which means that distance from here to here is 4 meters. So it's -4 in the y direction. Click on OK. You can see that you got a point here. Or what you could do, you can just hit 3 meters in the x direction and 1 meter in the y direction. So I just wanted to show you how you can copy the nodes. While you copy the nodes, you can also add automatically the beams or the columns, but I'll show you this thing when we will be designing or building, not here. Next point we got is this point. Alright, so this is 6 meters in the x direction, 0 in the y and 0 in the z. So next point is 6 meters, 0 0. We got this point. Now we'll just select this point and we'll hit Ctrl+C and Ctrl+V, and in the upward y direction we will have to copy it in 5 meters distance. So click on OK. We got this point. So now we have defined all the required nodes here. After defining the nodes, now we will draw the beams. So to draw the beam, click on this option that is available here, add beams option. So left click on it. After that, left click here. So move your mouse, reach here and left click again. Again left click here, take your mouse and left click here. So keep on doing this. Left click here. After that, left click and left click here. So just save it. So you see that we got a frame. So we don't have any plate, we don't have any surface or solid. Now that we have drawn the beam, so let us move to the general tab. So we are at the general tab now. What we're going to do is that we will be defining the beams and the columns. Okay, click on define and here click on rectangle. And so we got 3 columns and we got 2 beams. So we don't define beams and columns separately here. So we define a section and we can apply that as a beam or as a column. For the beams, for these 2 beams, let us assume the depth is 300 mm. Okay, so let us take depth as 350 mm, 0.350 meters, and the width as 230 mm, 0.230 meters. The material is concrete. The grade of the concrete is default, so that is determined by the software. So click on add. After that, we will define the column. So you can see the beam has been added. So 0.35 by 0.23 section. So let us define the columns. So the column will be 0.35. Okay, so 0.40, 400 mm by 0.40 by 0.40. Click on add, and after that click on close. So after assigning the beams and the columns to the structural members, now we will assign the supports. For that, so we should be at the general tab and support sub tab. Click on that. we got fixed support here, we got fixed support here, and we got pinned support here. So what are you going to do? We will define these two supports. So click on create. So first we will create the fixed support. Click on add. After that, again click on create. Click on pinned. And after that, click on add. So we got two supports. One is the fixed support, another is the hinge or the pinned support. So now what are you going to do? Either you can use cursor to assign or use the another method that you know. So we will use this option, and let us select this support too and click on assign. So we'll be selecting this point and this point as our fixed support, and after that select the second support. So and select this point. Okay, save, yes. We have assigned the support to our frame structure. After assigning the support to the frame structure, now we will define and apply load on it. So go to load and definition. After that, click on load case details over here. So we have to define the loads that we want to apply on this frame. So left click, and after that click on add. Here also we will add two kinds of load, that is the dead load and the live load. So number one load is dead, load type is dead, click on add. So second load is live load, so live load, and the load is live, click on add, click on close after that. Okay, so we have defined two loads, but we haven't yet applied the load on our structure. Let us define the loads within the dead loads. Left click on the dead. So here we got different kinds of load. Okay, this load over here will apply as the dead, this load also will apply as the dead, and this load will apply as the live, and this load also will apply as the live. So as I have already told you, as this is just an example of a frame, you have liberty to choose between the dead and the live load. But when you are doing a building, so certain loads are applied as the dead and certain loads are applied as the live load. You don't have any option over there. Okay, now let us define the dead load. Apart from these two loads, we got the self weight of the structure as well. First we will define the self weight. So left click on the dead, and after that click on add, and here check the self weight load option. So the factor should be -1, so we know why it is, and after that click on add. Alright, so the next we do is the member load, and the member load we got concentrated force. The unit value of the force is -10 kilonewton, and it is applied in the GY direction, and minus means the downward direction. If you see this, if we take this beam over here as an example, so if we apply on this beam, in that case the D1 distance here is 3 meters, and if we take this beam here, in that case the D1 distance is 0. So we will take this beam here as a reference and put the D1 value as 3 meters. Okay, so D1 is 3 meters, and we click on add. The next load that we are applying is the uniformly varying load of the dead nature. So this is the dead load of intensity 2 kilonewton per meter. So what are we going to do? We'll apply the linearly varying load. So we are applying this kind of load, okay, not this kind of load. This is W3. Check this option W3. The unit is, or the intensity is 2 kilonewton per meter. We are applying here. So this is positive X from left to right. We are applying from right to left. So it's negative -2 kilonewton per meter. So -2 kilonewton per meter. Direction is X direction. So click on add. So next load that we apply is the live load. So we don't have any dead loads. So click on close. After that, click on live option over here, live load, and click on add. So we got live load as 4 kN per meter distributed load, 7 kN per meter uniformly varying load. So let us apply this. It's a member load and it's a uniform force. So W1 is minus 4 kN per meter, and D1, D2, D3 are 0 in this case because we are applying in the full span. So there is no D1 value and there is no D2 value, and as we are applying at the center of the beam, there is no D3 value as well. Okay, so save it. It's minus 4 and the direction is GY, that is the Y direction. So click on add. So next load that we're applying is the linearly varying load, and here W1 is 0. So in this case you can see that there is no load at this point, so W1 is 0 and W2 is 7 kN per meter. So W1 or the load intensity at this point is 0 and load intensity at this point is 7 kN per meter, and the direction is Y, so it's -7, and click on add. After that click on close. So now we will apply these loads one by one. So first apply the self weight load. So click on self weight, and after that click on assign to view. So it will assign self weight load on all the structural members. So click on assign, click on yes. So this red color means that the self weight load has been applied, and also you can see the green color, the question mark color changes to the green color. So next we will apply concentrated load of minus 10 kN at 3 meter distance. So this is for this beam. So let us select this load and click on assign to the selected beam, and click on assign, and after that click on yes. You can see the point load has been applied. So the arrow looks very long, so we have to scale it. To scale the arrow, what are we going to do? So let us zoom out first. Click on this option that is available here, symbols and labels. So left click on it, and after that click on scales and click on apply immediately. So check this option, and point force. So let us increase the scale so that the icon decreases. So click on OK. So after that we apply linearly varying load of minus 2 kN per meter. So it is for this beam, so this column. So select this column over here. After that select this load and click on assign to the selected beam, and click on assign, and after that click on yes. You can see the load has been applied. If you want to check or edit this load, so what you can do, so just left click here, and after that click on edit. So you can see W3 is minus 2 kN per meter and the direction is X, so which means that we have applied a proper load. And if you want to change the intensity, you can change from here. And also if you double click on it and after that click on loading, you can see the loads that have been applied on this column. Okay, so now let us apply the live loads. Select this beam, so this beam got the live loads. After that select this load and click on assign. So you must check this option, assign to the selected beams, and click on assign, and after that click on yes. So the UDL load has been applied here. Now we will apply the UVL load or uniformly varying load on this beam. So select this beam, after that select this load, and after that click on assign. So check this option and click on assign and click on yes. You can see that the UVL load has also been applied. So if you select this load over here, you can see that you can see this load. Okay, and if you select this load, you can see this load, and the load that you have selected here turns blue and the another load turns green. Similarly for the live load, if you select this option, you can see the live loads, and the load that you have selected is blue and the other one is green. And if you select this load, so it turns green and it turns blue. To see the value of the loads that you have applied, so select this option again, so symbols and label option. So left click here. After that, here you can see loading display options. So click on load values and click on OK. So you can see the load value as well. So if you select this option, you can see the load, you can also see the load, and here also you can see the load value. Okay, all right. And if you suppose that you want the distance from this node to this node, then what you can do, click on this option, that is the dimension option, and click on display. So you can see the distance, this distance, this, and the distance between node to node. And if you want to remove this distance, click on remove, and after that click on remove. The distance will be removed. So let us also remove the force values. So click here, symbols and labels, and check this option and click on OK. Also, if you want to just measure distance from this node to this node, just click on this option. So display node to node distance, left click, and after that so select this node, and after that select this node. So the distance will be displayed as 3 meters. So just in case you want the distance between two specific nodes.